Hey folks, as I shared in my previous video, I started my journey diving into the React code base, and one of the first things I discovered is this fancy syntax called symbols. Well, this got me thinking, what exactly are symbols in JavaScript and why are they used here in React code base? So let's get to it. First thing first, what is a symbol in JavaScript? Symbol is a primitive data type, just like number, string, or boolean, but it has some special characteristics. Their value is unique, they are immutable, they cannot be serialized, and they could be hidden. So let me elaborate on this. Let's create two symbols called React element. One of the characteristics of symbols is they are unique in their values, which means if you create two symbols, even if they have the same description, the values are different. Let's run this script. As you can see here, those two values are not equal. You may be wondering if those values are not equal, so what's the point? How can we use it? Honestly, with this syntax, I don't know. But the one used in React Codebase is using the keyword for, like this. And by using the keyword for, we use a global registry for symbols. For instance, JavaScript will create a new symbol the first time we call it, but the second time it will use the existing one from the global registry. And now if we run the script, as you can see, they are equal. This is how we can reuse symbols in a code base. Also, we can get the description of a symbol by using the keyword key for and see what we get. As you can see, we have the key or the description react.element. The second point or the second characteristic is being immutable. If I try to change the description of a symbol like this will not work. Let's remove this one. As you can see, we are still having React element and not new description. The third characteristic, they cannot be serialized. If we try to put it inside a JSON stringify like this, let's remove, we don't need this anymore. You see, I get undefined. I mean, you cannot put it in JSON stringify, so you cannot get it as a JSON value. And the last characteristic, they can be hidden if they are used as a key in an object. Let's create a simple object. As you can see, there is just the first key that is logged to the console. You cannot access keys that are symbols using a for loop. So now that we have a basic idea about symbols, the next question is, what is the purpose of this property type of $$ type of React element? Well, here we have a comment that says this tag allows us to uniquely identify this as a React element. Interesting. But I found a great article from Dan Abramov that explains exactly the purpose of this property. Let's read some part of it. The interesting part, it was that's it. React elements are plain objects by design, while normally you create them with the react.createElement function. It's not required. There is a valid use case for React to support plain element objects written like I just did above. Of course, you probably wouldn't want to write them like this, but this can be useful for an optimizing compiler, passing UI, etc., etc. which means React is supposed to take objects like this, which are the React elements, and treat them as React elements. And the issue with this implementation is this one. If your server has a hole that lets the user store an arbitrary JSON object while the client code expects a string, this could become a problem. And the scenario is there is a server that is compromised where an attacker could save a JSON, and this JSON would contain a React element with malicious code that would be rendered like this. To have a better understanding, let's see a diagram. In a normal React application, what we do, we write some JSX. This JSX is transformed to pure JavaScript, calling React create elements that generates React elements that are plain objects. And then React take over this and does its work to render it to the screen. There is a legitimate case where we want something else to generate those plain objects. For example, a compiler. But having this implementation could lead to some code injection attack. And the scenario described in this blog post is the following. There is a server compromised where an attacker could save a JSON, a representation of a React element with some malicious code. The front end is expecting text from the server and try to render it. By rendering it like this, actually what it is doing is inserting this malicious code as a React element into the tree. So this malicious code will end up within the tree and will be executed on the front end in the browser. And this could be harmful. So to mitigate this risk, what they did is they introduced a unique identifier based on symbols. This unique identifier, it's this property type of. An attacker, even if he can inject a JSON, a React element as JSON in a corrupted or compromised server, he will not be able to add this property because this property cannot be serialized. And the React on the front end, when dealing with the React elements, checks if this property is valid or not. I tried to reproduce this attack, actually, to be honest. In the blog post, they say that React 0.13 has this flow. So I grabbed it from a CDN. I added the bubble to be able to use JSX and created a really simple code with the malicious JSON here with some JavaScript to be executed when user clicks on this link, and try to run it using npx serve to have a server. It's server actually, but unfortunately it didn't work. As you can see, I get the text and it's not executed as JavaScript. I believe this happens because Babel has some layer of protection against this kind of code injections, and it escaped the code that is coming from this object. Even if I couldn't reproduce the attack, I understood the big idea of this type of property using symbols. But I was wondering, how can I use those symbols in my day-to-day job? Frankly, I don't think I will encounter a situation like this where I can use them as unique identifier. to protect against code injection or something similar. But I found something interesting. If you look into the documentation for symbols in the MDN website, you will find some built-in symbols, what they call well-known symbols. And those symbols can be used to customize objects behavior. Actually, they offer a way to extend the behavior related to some native functionality. Let's imagine a scenario where I have to implement new data structure to handle trees. And I think about using class for this as follows. This data structure has two properties, root and children. I will just put text on them now, for now. I just want to illustrate how we can use those what they call well-known symbols. The first one I want to use is called toString tag. This one, and define how it should behave when it's passed to the toString function, built-in function. So at the moment, if I call, let's say, I call toString on this instance of tree and see what it defines. What does it log to the console? As you can see here, we have objects. It's not very explicit. It's not very clear. It doesn't help to understand which instance or which class is being logged to the console. What we can do here is use this well-known symbol to extend this behavior and give it a specific name. Here I gave it this name tree instance. And now if I run the same code, voila, you have this object tree instance. I know that is this one. I think this could be helpful for in some scenarios. At least I have it in my toolbox. If I need it, I can use it. And the second one that I found very interesting, it's iterating over an instance of this data structure. If, for example, now at the moment, let me remove this. This will not work. As you can see, it generates an error. But what I can do is implementing this behavior using the iterator symbol. And the syntax is as follows. You use the iterator symbol as a function name, and the declaration should return an object with next function that is return either value with the current value and done to false, or done to true when it's finished. In my case, what I want to do is concatenate the root and the children. Children is an array, root is just a string. So here I have one array with the root and children, and I just grab each element and return it from this new array. Once it's done, I return done. As you can see now, I have all the elements I assigned to this new tree structure. And that's pretty much it. This is what I learned about Symbol. I hope it was helpful for you, as it was for me. And see you on the next one. Bye.